Today we are going to discuss some simple examples on conjugate, modulus and argument. First example, if Z1 and Z2 are two complex numbers, prove that Z1 Z2 whole square is equal to Z1 square plus Z2 square if and only if Z1 Z2 conjugate is purely imaginary. Answer. First, take the left hand side. We are going to show that it is equal to right hand side. That is Z1 plus Z2 square is equal to, by definition of modulus, this is Z1 plus Z2. Z1 conjugate Z2 conjugate. On simplification, it will be equal to Z1 conjugate plus Z2 conjugate plus Z2 conjugate plus Z2 conjugate. Now we know that Z1 conjugate is equal to Z2 conjugate of conjugate. So in the next step we are going to write Z1 conjugate plus, instead of plus Z1 Z2 conjugate, I am writing this term first, then I am writing this one, Z1 Z2 conjugate plus Z2 conjugate. Now if this is my one complex number, then this is the, suppose complex number Z, then it is Z conjugate by definition, then it will be twice real part of Z, that is Z1 Z2 conjugate. So in next step we can write, this implies Z1 plus Z2 square modulus of Z1 plus Z2 square is equal to modulus of Z1 conjugate is this one, twice real part of Z1 Z2 conjugate plus Z2 modulus of Z2 square. Since Z1 and Z2 conjugate is purely imaginary, it is given in the question, purely imaginary. So real part of Z1 Z2 conjugate is, therefore this Z1 plus Z2 modulus square is equal to Z1, this is equal to 0, Z2 square. So we get our result. Next one. Question number 2. If Z1 and Z2 are any two complex number, then Z1 plus Z2 whole square plus Z1 minus Z2 whole square is equal to twice Z1 square plus z2 square. This is known as parallelogram law of complex number. Parallelogram law of complex number. Proof. Take the left hand side, that is z1 plus z2 whole square plus z1 minus z2 whole square, and by using definition of modulus, that is z1 plus z2, again conjugate of z1 plus z2, that will be equal to my z1 conjugate plus z2 conjugate. z1 minus z2, z1 conjugate minus z2 conjugate, and this is equal to my, if I expand this one is equal to z1 plus z1 conjugate, z1 conjugate z1 conjugate plus z1 z2 conjugate plus z1 conjugate plus z2 conjugate. This is for the first term, and for the second it will be z1 conjugate and minus z1 conjugate, z1, this is z1, then again it will be minus z1 conjugate plus z2 conjugate. Look here, if you remove the bracket, here, then here z1 z2, this is z1 z2 conjugate, so this cancel with this one and this cancel with this one. I will left with 2 z1 per z1 conjugate and 2 z2 conjugate. So in the next slide it will be equal to 2 z1 conjugate plus 2 z2 conjugate, and this is equal to here 2 z1 modulus square z2 modulus square. So 2 modulus of z2 square, take 2 common, this is z1 square plus z2 square. So we get our result, this is left hand side is equal to right hand side. With that, I would like